Good morning, class. Today we're going to be working on comparing fractions using benchmarks. So let's look at our essential question for the day. How can you use benchmarks to compare fractions? I want you to think about that. What are benchmarks? Well, benchmarks are known amounts, something common, that you can use to compare another amount or to compare something uncommon. For example, we're going to take three numbers. We're going to take 0, 1/2, and 1. These are common numbers that we're going to use to compare fractions. So the fractions we're going to be comparing today are 5/12 and 9/10. Now I notice when I look at these fractions, I can see that the numbers on the bottom, their denominators, are different. That makes it difficult to compare. This is where we can use benchmarks to help us compare these fractions. So here we have 5/12, and we also have it represented visually so you can see that it is 1, 2, 3, 4, 5/12. I'm going to compare that to my benchmark numbers, 0, 1/2, and 1. Now I can tell that there's not 0 of something here because I see 5/12. Now I'm going to look at my next benchmark number, which is 1/2. And then I'm going to look at my next benchmark number, which is 1. I think that 5/12 is closer to 1/2. Now I'm going to take my number 9/10 and I'm going to represent it visually. I have something that is cut into 10 pieces, and I have 9 out of 10 of those. So I'm representing it right here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Once again, I'm going to use my benchmark fractions. I have 1/2 and 1/2. And I can see that this one is closer to 1/2 than it is 1/2. And I bet you're probably thinking, if I just added one more tenth, that could make it a whole. And you're right. 9/10 is close to 10/10, which 10/10 is equal to 1. So as we determined, we figured out 5/12 was closer to 1/2, our benchmark 1/2, and 9/10 was closer to the benchmark number 1. And we used our benchmarks 1/2 and 1 to help us determine how these fractions compare to one another. I'm going to use a number line to show my benchmarks. I have the number 0, 1/2, and 1. 1/2 is halfway between 0 and 1. Next, I'm going to determine where 5/12 falls along this line. So I've drawn lines on my number line to represent 12. I've divided my line, my whole line, into 12 tick marks, or 12 lines to represent one whole, which is 12 out of 12. If I'm thinking of halves, I'm going to think of what's half of a number. So if I'm thinking of half of 12, what would be half of 12? I'm thinking of 6/12. If I want to find where 5/12 comes on the number line, I just need to count 1, 2, 3, 4, 5. Because this is the fifth line out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 lines. So my fifth line, 5/12 would go right here. So using my benchmark, I can see that 5/12 is close to 1/2. Now I'm going to take my number 9/10 and I'm going to use my benchmarks to see where 9/10 falls on the number line. So I've divided up my number line into 10 marks this time because the denominator is 10. This one's cut into 10 pieces, or it's 10 parts. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. My 1 whole means 10 out of 10. If I'm thinking of half, I'm going to think what's half of 10? 5. 5 is half of 10. Now, if I've been thinking where does 9/10 fall on the number line, well, 9 is bigger than 5. So I know 9/10 is going to be somewhere over here. I can count the lines. 1, 2, 3, 4, 5, 6, 7, 8, 9. Or, as some of you might have been thinking, well, there's 10/10, so 9/10 must be right here. If we're looking at benchmark fractions, 1/2 or 1 whole, we can see that 9/10 is closer to 1 whole. So after taking our uncommon fractions and comparing and using benchmarks to compare them, we found that 5/12 was close to 1/2 and 9/10 was close to 1 whole. And we know that 1/2 is less than 1 whole. So that means 5/12 is less than 9/10. And we used benchmarks to compare these fractions.